Hi folks, this is page 245, number 19 from the Unit 4 assignment. So they're asking us to prove this identity. Okay, so step number one, choose a side. I don't think there's any choice in the matter. We're going to work with the right-hand side here. Okay, and here I've got this 2 on the outside. Okay, and right off the bat, I can see that I have no choice in the denominator but to expand this to 2 sine x cos x. Okay. I see that this factor of 2 in the numerator is going to reduce with this factor of 2 in the denominator. Okay, so before I go and do any kind of distribution, take care of that right off the bat. Okay, so if I look at this first term in the numerator, I've got cos x. Okay, and not much I can do there. I have to expand that to 2 sine x cos x. Okay, here though I have to make a decision. What do I do with the cos 2x? Okay, well, I've got sines and cosines in the denominator. Here, if I take a look, I have 2 sine x cos squared x once I multiply that out. Well, here I've got a sine x, so it seems to make sense to use this version of the double angle formula, 2 cos squared x minus 1. Okay, because once I do that, I realize I'm going to have a 2 sine cos squared x, and here I'm going to have a 2 sine x cos squared x also. Okay, so it looks like this is the way to go. So when you're deciding on which double angle formula to use for cos 2x, again, you really need to take a look at what else is happening in the terms around. Okay, so let's see what happens when we simplify this. So here we've got 2 sine x cos squared x. Here we've got minus 2 sine x cos squared x, so that's very nice. Okay, and here we got negative sine x times negative 1, so that's plus sine x. Okay, all over sine x cos x. Okay, these two terms just subtract to 0, so we're left with sine x over sine x cos x. Sine x in the numerator and denominator reduce, and so I'm just left with 1 over cos x, which of course is equal to secant of x, which is my left-hand side. Okay, and there you go. We've proved this identity. Okay, so a couple of things to recap. Okay, before you start doing any kind of distribution, before you start doing any kind of algebra, it's usually best to do some trigonometry first. So it made sense to first expand this, see that the 2's cancel out, expand these two, and more importantly, this second expansion in the numerator, the cos 2x, is I didn't just choose this blindly. I looked to see what I already had in my other expression. Okay, that's it for this one.